All right, everyone, we got lesson number 3 that's going on here. Today, the emphasis is going to be on the equation. We saw the proportion yesterday, and if you were kind of hoping for something different than the proportion, well, we've got something for you today. If you love the proportion, you can still use the proportion, but we do want you to see other techniques because some problems are just easier to solve using different techniques. So your percent equation, if we kind of go back to what we saw before, we're going to write this up here, is we take the parts, we set it equal to when you take the percent and you times it by the whole amount. So we're still dealing with part and whole. We still need to figure that out, but we can set up an equation rather than setting up our proportion and then solving the equation that's out of it. So we can still use the visual to help us set up particular items. So for example here, we got the members of a club. They're making friendship bracelets to sell to raise money. Ann and Emily made 54 bracelets over the weekend. They need to produce 300 bracelets by the end of the week. What percent of the bracelets were they able to produce? So, okay, so setting up their percent-wise goes from 0 all the way up to 100. I don't know what the percent is. I do know the whole amount. They want to get all the way up to 300, and so far they've made 54. So again, I don't know what the percent is we're dealing with. So again, the visual helps to show you where we're setting things up. So what's the part? Well, the part's 54. All right. What's the percent? I don't know, so that's my X. What's the whole amount? Well, there it is. It's the 300. So again, the visual helps you set up. You can just jump right to it. Now simply all we're going to do is solve our equation. So we can divide both sides by 300. What we want you to notice here is what happens when you type this into your calculator. And this goes back to why we ended up spending time converting with decimals, percents, and fractions. When we do our division problem here, we do get 1800ths. But the thing about it is this is simply a decimal. So we need to change it into a percent. So it is 18% that we're dealing with. 1800ths, again, many ways of doing it there. 1800ths, that's a fraction. There it is. It's out of 100, so that's why it's 18%. Move the decimal 2 places to the right. Any of those particular ideas are going to work there. The main thing to realize is they give you the decimal. Now, if you think back to your proportions, the decimal is already built into it there. It was already percent out of 100, so you did not worry about doing any particular conversions. So that is something we do have to deal with your percent equation. So let's see, we got Anna again here, produced 32 bracelets of the 54 bracelets produced, wow, by Emily and Anna over the weekend. Compare the number of bracelets Emily produced as a percent of those that Anna produced. So once again, visual-wise here, 0, I don't know, 0%, I don't know what her percent was, but I do know it goes up to 100%. And again, she made 32 out of the 54. All right, so compare the number of bracelets Emily produced as a percent of those that Anna produced. If we go ahead and solve here, the part, 32, the percent, don't know, times the whole is 54. So we divide both sides by 54. So we do our 32, we divide it by 54, and we get, oh my goodness, we get somewhat of a decimal. Okay, so then the other question here is, and this is when we look at it sometimes, is it, should I just reverse the numbers and just do 54 divided by? Well, okay, we don't want to fall into that particular role of, wow, I got some sort of a number there, lots of decimals, this isn't good. No, all right, that's not the case that we're after. So let's see what we've got there. And in our decimal here, we've got 0.59 and then 2 and then 59. So we get a repeating decimal that is there. So, and then equals our X. So we change it to a percent here. I'm going to let you know, and again, this is part of what we'll do is we'll take some additional directions here. We're going to round, all right, and we're going to round to the nearest percent. Now, the only reason why we're allowed to do that is because I'm telling you to do so, all right? Otherwise, we'd want to write it out. So, again, we've got repeating that's going on here. So if we move it 2 spots to the right, we're going to have 59.2 and then 592 and then again the 592. So we talk about a repeating decimal here. That's what we are after. Now, if they said to the nearest percent, all right, then we would say 59%. So again, we do want to recognize both of them that are there, but just don't fall in love. And let's think about it there. Who produced more? All right, there was 54, and she produced more of them, so she would have a bigger percent there. The number of bracelets that Emily produced as a percent to those that Anna produced. So, and I don't want you to fall in love with there. So this is where we'll kind of clarify. And the more I think about this question, I'm not as much as in love with it because it's getting more wordy than anything. We would want to compare those. So Anna, all right, produced, all right, 59% of the bracelets. So again, so the more I start looking at there, I'm not in love with the wording there as much, but I think we'll talk more about that in class. So compare the number of bracelets that Anna produced as a percent of those that Emily. So this is where we're kind of going back and forth here a little bit. So let's hold off on that particular one because again we'll deal more with that in class because of the wordiness that's there. Let's keep going here. All right, so we got 750 students in the 7th grade class and 625 students in the 8th grade class at Kent Middle School. What percent is the 7th grade class of the 8th grade class at Kent Middle School? Okay, so here's part of what we're looking at as we kind of do our visual here. And we're trying to figure out, my goodness, who's the part, who's the whole? Well, part of the percent equation here is, check this out, is of. The word is your equal sign. Of means to multiply. So when we look at this, it's saying what percent, all right, is the 7th grade class of the 8th grade class. So we do have kind of key words that are in there that can kind of help us to set things up. I'm going to go visual here at the beginning, all right, 0%, 100%, 15. Oops, I thought I had 15% there. Never mind there, all right. I'm looking at the wrong page in the packet there. Let's go back here. All right. Some days we just have bad days recording here. All right. So what percent of, all right, so I'm going to start over here. That's what I'm just going to simply do. All right. Sometimes you just got to do that, people. And this is one of the reasons why I don't redo your videos there is to kind of show you that sometimes I struggle as I go through them. And sometimes you just kind of need to regroup there. So what percent is the 7th grade class of the, okay, so part of what we're looking for here is this is what your part's going to be. This is what your whole is going to be. Now let's look at why. What percent is the 7th grade class of the 8th grade class? That word of is a key indicator that that is the whole amount. The part, that's the key indicator is. So that's certainly something that's going to kind of help you out as you look at there. So what percent? So the 7th grade class is the part. So that's my 750 because that's with your 7th graders. Percent, don't know, times the whole of the 8th grade. So that's the whole there. So when I solve my equation, I divide both sides by 625. Notice what happens here. Notice your number that you've got. Bigger than 100%. That's okay because that's more of growth. So our calculator says this. We're going to go 2 spots to the right. So it's going to be 111 and 1/10 repeating percent that we're looking at. So we do get a larger number that we are after. It does say that in question 2 there, if it exceeds 110%, they're going to add on classes. So yes, we can see that. I'm not as worried as we do that particular one. I mentioned more with your setups there. All right, now this is the other variation of the problem we want to wear. At Kent Middle School, there are 104 students in the band and 80 students in the choir. What percent of the number of students in the choir is the number of students in the band? Oh my goodness. So sometimes what we can use here is keywords. So what percent, all right, and this is the idea of what percent of the number of students that are in choir is, remember that word is there, the number of students that are in band that we're dealing with there. So is and of, so when we set things up, yeah, take a look. 104 students, all right, in the band, all right. So the band there, all right, and there's a key word there. So that is our part that we're looking at. The of helps us figure out the total amount. So we've got key words that we are after here. So do a little division, 104. Let's divide that by our 80. Again, don't worry about numbers if they're not coming out clean, all right. But this one came out nice. All right, change it to a percent. So we've got ourselves 130%. 2 to the right if you want, 1 3/10, however you want to write it out. All right, last one here. We got Kent Middle School. The breakfast costs $1.25 and lunch costs $3.75. What percent of the cost of lunch is the cost of breakfast? So again, that of and that is certainly going to help you out. So your setup here, $3.75 equals $1.25 times your x. Now, could I say x times $1.25? Absolutely. We can flip-flop those around. Divide both sides by $1.25. Punch that into your calculator. And you get a nice crisp. I kind of feel, you ever do that? Punch something in your calculator and feel like, why? That was mental math I should have used there. All right. So what percent of the cost of lunch is the cost of breakfast? All right. 300%. All right, and again, we can kind of use the key phrases of that is and that of. The is always going to be the part, and of is always going to be the whole. Do you like what I've done here? Do you like what I've done? Is the part, so wait a second, is the part, what percent of the cost of lunch? All right, so wait a second. Should I have it flipped around and do something like this? And again, we don't want to get into the, well, this looks nicer, but let's think about it there. What percent of the cost of lunch? Of is your whole amount, and lunch was $3.75. All right, so let's do this. And part of the reasons here is I can catch it as I'm punching in, looking at my answer. And this is why we talk about kind of, addressing it there. I'm getting 0.3 repeating. All right, so if I go 2 spots to the right, that's 33.3%, because they're saying what percent of the cost of lunch is the cost of breakfast. So this is part of what we're going to look at here, is focusing on the wording and how we can help ourselves out. And how can we look at the wording to know that's an unrealistic answer. It should be smaller versus than 100% versus then it should be larger than 100%.